Okay, so we're going to be doing some macroeconomics. We're looking at a Solow-Swan model with endogenous technological progress. So I'll write down a few rules and then we'll get right into the business. Okay, so we've got similar rules to when we did our Solow-Swan, except you'll notice there's an H here. What's this H all about, you may ask? Something I should be asking. Ly represents the amount of workers in the manufacturing sector, and Hy is their respective human capital, okay? Yeah, Hy is the human capital of each of those workers. So I can write that down. My writing is really messy, but it doesn't really matter because I'm going to explain it anyway. Workers in manufacturing, the human capital of each worker, and then you've got workers in the research and development sector. So that's LA, which is equal to this. It's the same thing, and then obviously your whole labor force, which is just the sum of your workers in manufacturing and your workers in the research and development sector. We're only categorizing workers in two different places. So our question today is, how do we get this into per capita terms, right? So we've got our classic big YT over L, big KT over L, and we can get our per capita, but how is this going to interact, right? So let's get started. So this is our first step. We know that we're leaving A like this. We know that we're bringing Y down to the per capita, and we're also bringing K down as well. Ly is equal to L less LA because this holds true, and then therefore Ly equals L less epsilon L, okay? So what we can do is we can rewrite, I'm just going to rewrite this here, Hy, and then L less epsilon L, all to the power of alpha over L. And at this point, you're going to see the solution. Well, we can just factor out L. So we have L, 1 less epsilon, Hy, right? That's an H by there, that kind of looks like a B. And now, well, your L's are going to disappear, and your final answer is going to be YT equals AT, KT 1 less alpha, HY to the power of alpha, 1 less epsilon to the power of alpha. This is correct. So this is your per capita income or output function at time t for the Solow-Swan endogenous technological progress model. And then obviously what's sort of fun here is LA is the labor force in the research and development sector. So what's kind of fun is, well, the portion of the labor force involved in the research and development sector is epsilon. So obviously epsilon is in between 0 and 1. And it makes sense because epsilon cannot equal 1, because as you can see, when epsilon falls to 1, when epsilon goes to 1, if it ever did, then you would have 0 output. You wouldn't be making anything. Because it's all multiplied with each other, right? So that becomes 0. And then you're toast. You are toast. So therefore, epsilon always has to be in between 0 and 1. Right? It's just the way it is. So there's your answer. Thank you for watching.